Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 6, 2025, about 5 days ago. The standout idea is token-level control for text-driven image editing, which gives smooth, disentangled edits by steering the sparse AutoEncoder space while leaving the diffusion renderer untouched. The paper is titled SAEdit, Token-Level Control for Continuous Image Editing via Sparse AutoEncoder, and as we will see later, the results are both precise and easy to dial in. Beyond the core method, the study shows model-agnostic deployment, real image editing via inversion, and stronger fidelity through a time-aware edit injection schedule. Alright, the introduction set the stage for token-level control. Figure 1 presents the pipeline. A sparse autoencoder lifts text embeddings, direction finding isolates a concept like laughing, and the edit applies only to the chosen token in a text-to-image model. The panels on the right illustrate continuous control, since raising omega t strengthens the smile while the rest stays stable. The top row targets woman, and the bottom row targets kid. So, Figure 2 contrasts naive token interpolation with the sparse autoencoder approach. The figure shows two examples with multiple columns that increase edit strength, which makes differences easy to judge. The top row uses T5 embedding interpolation and causes entangled changes. The left example barely makes the child look terrified, and the right example alters unrelated elements while aging the subject. The bottom row applies sparse directions and preserves identity while achieving the intended edits, so the changes stay local and clean. So, the previous figure contrasted naive interpolation with sparse directions. Figure 5 illustrates how the edit is actually applied. The target token is encoded with SENC, a sparse edit direction is added with a controllable omega t scale, and the result is decoded with SDEC. The decoded token embedding then conditions the diffusion block, so the image reflects the change while layout stays intact. The example targets the word man and produces a happier face. So, Figure 10 presents the quantitative head-to-head, plotting inverted LPIPS on the x-axis and delta 5 QA on the y-axis, where the top right is better. The blue curve shows smooth increases in edit strength that stay farther right and higher than others, which signals both stronger preservation and higher prompt adherence. Competitors trend leftward or flatten, so edits either drift or weaken. The legend at left lists each baseline for reference. Alright, the previous figure reported metric curves. Table 1 now summarizes the user study, which measured pairwise preferences for image preservation, prompt adherence, and overall quality. Our method beat Flux Context with guidance at about 70% overall and beat the large language model variant at about 70% overall. It edged Concept Slider at about 71% overall, and it strongly surpassed Flux Space at 93% overall because prompt adherence hit 92%. Two takeaways stand out. Token-level steering and a sparse autoencoder delivers smooth, disentangled edits, and the time-aware injection keeps layout and identity intact while scaling strength. The model-agnostic design suggests a practical control layer for future text-to-image systems, despite limits on extreme out-of-distribution asks. Thanks for listening. I am Alex, signing off.